Above all, when we deal with projectile motion, we do keep in our mind that it is motion under gravity. And one basic characteristic of motion under gravity is that in its entire motion, you choose any point. This point will be traced while going upward and also while returning downward. Means this point will appear twice in the whole journey. Similarly, here also, we'll consider 2 points. These 2 points are not going to be at the same place, but we'll consider them to be at the same height. If you consider 2 points at the same height in projectile motion, speed will be same. Remember, I again emphasize, I underline, speed will be same at these points. Don't say velocity. Speed is same. Why I am repeating, why I am emphasizing this thing? Because they are having different direction. So here we would say, in motion under gravity, we used to say that at the same point while going and returning, the velocity will be equal and opposite. Here what we say, at the 2 points of equal height, the speed will be same. We can't say velocity is equal and opposite. See, its opposite will be this way. Similarly, in projectile, in motion under gravity, body goes with one velocity and return with equal and opposite velocity. Here, body was thrown at one velocity, it returned to the same level with the same speed. Don't say velocity. These two are not equal and opposite. Value will be same. Their value is same, but they are not opposite in their direction. One thing. Second, when you throw it, horizontal velocity, say this is angle theta, this becomes horizontal velocity. Let's consider first of all this only. I told you horizontal force is not there. No force other than gravity. So along horizontal line, there is going to be no acceleration. At all the points, any point you choose, the horizontal velocity will be same. Here also, this velocity will remain same. Here too, it will be u cos theta at all the points. So horizontal velocity is constant everywhere. You want to find the distance along horizontal direction, then in that case, velocity into time. You need to remember only these two relations if horizontal direction is considered and projectile motion takes place along two axes. One axis is this one. That way you can say that half of the chapter we have covered. Now we need to know in detail regarding vertical direction. That's going to be a bit complex in nature. Because G is there, because acceleration is there. Acceleration G, acceleration due to gravity, that always acts downward. Because of its presence only, we use all the equations of motion in vertical direction. Like first equation, when you consider vertical direction, first equation will be u minus gt. In place of u, the initial vertical velocity, see here. This is velocity of projection. This is horizontal component. Now the vertical velocity will be u sine theta. I'm sorry, it's a bit inclined, but consider it's vertical velocity u sine theta. Initial vertical velocity. This will go on decreasing, and if you want to find somewhere velocity in vertical direction, use this equation. Remember, I am using the first equation. This is final, this is initial, this is acceleration. But since in vertical direction, this is vertical velocity final, the point you may choose. This is initial vertical velocity. In place of a, you have to put minus g and t. Similarly, if you want to write second equation, it's going to be u sine theta t minus half gt square. Here I have chosen second one, s equal to ut plus half at square. Now, let's consider the two axes again separately. If it is constant velocity, in that case, x t graph will be a straight line. And if there is acceleration, y t graph along vertical axis will be a parabola. And on superimposing both, we get finally the trajectory of projectile as a parabola.